I'm going to share the presentation with you. So this experience I'm going to talk about has been implemented in the degree of business administration in the subject of microeconomics, which is taught in the second year. So the motivation is that it's time to reconcile ourselves with bio-waste. We may have thought that the progress was to be able to put our waste in a garbage can, and then perhaps it goes to an incinerator and anymore. However, although this has the merit of simplicity, it cuts the ancestral cycle of organic matter and also has direct effects of encouraging waste and also emitting many greenhouse gases, and additionally deprives the soil of its basic food. So I'm going to share the analysis that I have built with my students and hope to give you the desire to take the plunge. So perhaps we are not aware of the huge amount of food waste that is around us. It comes from green waste, plant leftovers, coffee grounds, frying oils, kitchen waste, tea, meat and fish, and even paper napkins. So the global plastic production reached almost 360 million tons in 2018. In contrast, bioplastic production capacity was only 2 million tons. That is, represents less than 1% of global plastic production. Currently, around 80% of all plastic produced worldwide is not recycled or reused in other ways. However, still now, the cost of producing bioplastics is much higher than petroleum-based plastics. One reasonable option to reduce the manufacturing cost of bioplastic would be to use suitable waste and byproducts as feedstock materials. So first of all, I'm going to explain different concepts. First, we are familiar to circular economy. The circular economy offers new business opportunities by changing the traditional linear material use model to a more sustainable, efficient, and circular one. It is a sustainable concept that focuses on keeping material value at a maximum by applying the 3 R's rule: reduce, reuse, and recycle practices, which benefit society in the aspects of economy and environment without aggravating the burden or primary natural resource extraction. So circular economy is defined using the following pillars. First, preserve and enhance natural capital. Second, optimize the performance of resources in use. And third, promote system efficiency. The second concept is green economy. So in a green economy, employment and income growth is driven by public and private investment in economic activities, infrastructure, and assets that reduce carbon emissions and pollution, improve energy and resource efficiency, and prevent the loss of biodiversity and ecosystem services. However, the substitution of one product or process for another that is more green or ecological may have unintended consequences, including collateral damages. And I have 2 examples. The use of maize as a feedstock for biofuels and bioplastic has increased the cost of tortillas which are made from maize. The pursuit of bioplastic may further endanger food securities for some population, for example, in Latin America, and this is not sustainable development. Another example concerns the use of palm oil for biodegradable soaps, which has led to the destruction of huge tracts of rainforest and within the habitat of the orangutan. And again, this is not sustainable development. So the new concept is blue economy. The blue economy is an hybrid form using circular economy and green economy. The circular economy still focuses on companies that are based on a single core businesses. The blue economy, by contrast, shows that having a portfolio of businesses can create more value, not only in economic terms, but for society and nature as a whole. In the green economy, everything that is good for you and the environment is expensive, most of the times. These high prices are often justified because local producers cannot take advantage of economies of scale. In the blue economy model, you start from community resources and build a commitment to the resilience of your community. If there is no waste, you can generate more value and create more jobs. Finally, the last concept is about food waste. The FAO defines food waste as losses of food in quality and quantity through the supply chain process that occurs at the production, post-harvest, and processing stages. Around 1.3 billion tons of food are lost or wasted each year worldwide. For the European Union, it is amounted to 90 million tons of kitchen waste. Perhaps we could think that a good alternative would be to feed animals. However, it has become illegal due to the concern of disease control. Therefore, the valorization of food waste through the production of value-added products may be an ideal and practical end use. So the original idea came from Professor Yoshihito Shirai in 2000. The professor was working in the Institute of Life Science in the Kyushu Institute of Technology, Japan, and he observed how restaurants in Japan discarded large quantities of food. As a result, there was an increasing pressure of the local landfill. So he combined this amount of food waste and also the desire to reduce carbon emissions. And he invented a process to obtain a starch from food waste, and from a starch obtain bioplastic. So the starch content is lower than the original source of a starch, which is corn. This model is convincing, and the environmental benefits outweigh any other bioplastic method of production. So from restaurants, you obtain food waste. The restaurant pays for food waste collection. The food waste collector produces plastic from a starch, so this creates new jobs. And from this plastic, you obtain bioplastics, which are used by consumers. So this is the whole chain. The main objective of this experience was to analyze the net social benefits of switching from petroleum-based plastics to bioplastics based on a cost-benefit analysis. The concept of cost-benefit analysis is a tool to evaluate a project in order to help the public sector to inform their decisions on the pursuit of bioplastics. So students compare two scenarios. The status quo scenario in which the production of bioplastic is not introduced and only the production of fossil-based plastic is used. And the second scenario where production of fossil-based plastics is forbidden and the production capacity is transformed using local food plastic to obtain bioplastic. So all of us are concerned with these problems: companies, families, communities, large-scale distribution, hospitals, schools, universities, and restaurants. There is an important report, the Food Waste Index report, that is available online and provides information about the amount of food waste per capita in annual terms. For example, in Finland, it's around between 64 and 67, in Poland, 56 kilos per capita. So students were divided by groups, and each group had to choose a country or a city. So taking into account the amount of food per capita, they had to obtain the global amount of food waste considering the global amount of population in the particular city that they were studying. So you have countries throughout the world. So they had to take into account on the cost side the investment cost of a new plant, the production cost, and the water treatment cost. On the benefit side, obtaining secondary products, for example, ethanol, the reduction of carbon emissions, and the reduction of hazardous waste. Also, the disadvantage of bioplastic is that the production technology is more recent. So petroleum-based plastic are produced using a technology that has been developed for more than 60 years, so it's in a maturity stage. So in some stages, it's cheaper, although it's more pollutant. So consequently, the traditional processes require less energy per ton of product than the new technology, which is an embryonic stage. So this is an example of the final report that this group of students had to elaborate. So in this case, they compared the production of 100,000 tons of plastic, whether bioplastic or fossil-based plastic. So they had to consider production cost and capital and technology. And in this case, we observed the difference because it's much higher for the case of bioplastic, because it's more rich in technology. As soon as we have learning economies of scale, we hope that this investment cost will be reduced. They also had to take into account the land cost, the indirect cost, greenhouse gas emissions. In this house, they are much lower for bioplastic, 30 as compared to 143, and the opportunity cost of land, which is the same in both circumstances. So in a first stage, total costs are higher for bioplastic as compared to fossil-based plastic. However, if we consider the direct benefits, not only from bioplastic, but from other secondary products that are obtained, and also the indirect benefits in terms of reductions of carbon emissions, the total benefit for bioplastic, 594, is much higher as compared to the total benefit of fossil-based plastic, 143. Therefore, the net benefit is positive, although small, as compared to a huge negative net benefit for fossil-based bioplastic. And this is only an example, but it repeated for all cities analyzed by students. So they became aware by themselves of the difference of applying different production technologies, obtaining benefits, and at the same time reducing carbon emissions. So students have become familiar with new approaches to economies that are not usually covered in traditional textbooks. The blue economy is a way to reconcile economic profitability, environmental care, and local and regional approach. The students have become familiar with the reality of food waste. They have also become familiar with economic and environmental vocabulary in English, which is also a drawback in many subjects, that students should become familiar with English vocabulary, but many times it doesn't happen. And finally, the exhibition of their work has helped them to learn about the realities of other cities around the world, promoting the concept of caring for the environment as a global concern. So thank you for your attention. That's my email address, and that's all. Thank you very much for this opportunity.